Welcome. My name is Bob Ballantyne, and I'm a distinguished engineer within Dell Technologies and the lead architect of the Developer Platform Services Group within ISG, or Integrated Solutions Group. Today, we're going to talk about the developer-ready platform and how we enabled rapid development of its services to make it easier for our developers of the platform. The Developer-Ready Platform, or DRP, is a product which our team provides to over 10,000 developers within ISG. This platform is composed of a suite of North Star applications, Slack, Jira, Artifactory, Jenkins, GitHub, etc., running on common shared hardware and brought together with microservices based on our microservice framework. Most of our services communicate through topics on a Kafka bus. All the product teams within ISG use these tools running on common hardware. The developers within the Developer Platform Services Group are the ones who develop the services. The DRP component microservices brings all of this together to form an event-based system which uses a GitOps model to synchronize the running system with our GitHub source of truth. The developer-ready platform must enable engineering teams to achieve a higher velocity with faster feedback pull requests while delivering a better developer experience using these tools. The developers themselves are spread across over 100 business units within Dell, and we provide everything they use to securely build, test, and deploy their code in an efficient and reliable manner. For this, we need a multi-tenanted system to allow each BU to operate independently. We also require that the system be dynamic, since new groups, new hardware, and our labs are frequently being added or removed. Lastly, but equally important, we must be geographically distributed and provide SLOs which guarantee our uptime and rapid response. As mentioned, our microservices bring everything together. Using microservices within Kubernetes provides a lot of benefits around reliability, scaling, configurability, and observability. When developing these microservices, we found that giving developers too much freedom had a detrimental effect on the system's overall maintainability. We ended up having to find a balance between freedom for the developers and a guided approach, which brought to light the need for a common microservice framework. Next, my colleague Amit Roy is going to discuss some of the details of the microservice framework.
Hello, I am Amit Roy. I work in the same organization as Bob Ballantyne, and I'm a distinguished member of technical staff. The microservice framework reduces the cognitive load on the platform developer and provides a golden path to the developer. It guides the developer to design, develop, and test the microservice. After deployment in production, the framework helps in monitoring and in everyday support of the microservice. Please note that I specifically left out deployment of a microservice since the framework does not play a direct role in that. The deployment in Kubernetes can be complex, and we have a separate module for it. The complexities of the underlying technologies, as example Kafka, Kubernetes, Prometheus, Opentelemetry, etc., are reduced by exposing them as configuration along with simple APIs. In the next few slides, I'm going to get into more details on these. The framework helps in establishing design patterns. In developer-ready platform, we have embraced an event-based, loosely coupled approach, mostly choreographed as opposed to orchestrated. The framework makes it easy to embrace the above design patterns. If anyone wants to write business logic to support some other pattern, it stands out. The developer can still add a new pattern. The framework does not take away that freedom, but it gets flagged, and as a result, it triggers more discussion within the organization. Configuration as a code is known to everyone. It helps developer deliver functionality by writing fewer lines of code. Opinionated APIs, with its rich error handling, supplements configuration as a code. One example is a GitHub API with built-in rec limit, automatic retry on error handling, GraphQL-based queries. An example of context-aware logging is, suppose a microservice deals with a pull request. In that case, automatically log the pull request number and other details like repository name, branch name for every log message, freeing the developer from including it in his business logic. The framework supplies the suitable mechanism for this. Unhandled exceptions in business logic are handled by the framework and the corresponding event dumped in a dead letter queue. From there, it is picked up by the relevant self-healing system for further processing. The framework helps to collect some default metrics. As example, time spent in a Kafka message handler, an exception has occurred in a handler. It generates a default set of trace data. If the developer wants to add additional metrics or trace, the framework provides relevant APIs. In a multi-tenant system, configuration management can get complex, where some configurations are supplied by the platform itself, while some others are supplied by the tenant. Some platform configurations can be overwritten by the business unit. The framework consolidates multiple configurations into a single dictionary and presents it to the developer, making his life easy. Without this, the developer must be aware of the source of his configurations while writing his business logic. Additionally, the framework provides lots of utility functions. Examples are clean shutdown, auto monitor, etc. The framework abstracts out multiple components, which you can see here on the slide, and exposes their functionality via configuration as code, along with the relevant APIs. Microservice developer imports the relevant components to use it. We are adding new components as and when the need arises. One such example is notification, which we added only recently and not shown here. In view of time, we are going to discuss more details about utilities, Kafka, and jobs, which are highlighted. We will only highlight some configurations in each to give the listener some feel about it. Here we show some configurations for utility component. The first one is signal handler wait time. If a microservice receives a termination signal, the framework catches it and initiates a clean shutdown of its component. The time tells the framework how long to wait before exiting the microservice. The next one is max attempt. If the developer uses the attempt decorator for a function, the framework will retry the function the specified number of times in case of failure. Additionally, it will wait for the specified number of seconds between each retry. Monitor is an important one. If set to true, this flag allows Prometheus to collect some default metrics from the microservice without the developer needing to take any explicit action. Next, we show some configurations for Kafka. Majority of the configuration fields are self-explanatory here. The developer can launch multiple Kafka consumer, each in its own thread. Many of the parameters are open source options, which are passed to the open source APIs. I'm going to skip those and directly go to the filter module and the handler module. In the handler module, the developer writes the business logic, which is invoked when a Kafka event is received. The framework loads the module and executes it. Since the microservice may not be interested in all the events received, The filter module allows the developer to filter out messages. If the filter module returns true, only then the handler is called. Similarly, there are configurations for Kafka producers, which we are not showing here. The framework has a rich Kubernetes job management functionality, which supplements native Kubernetes capabilities. It allows the developer to spawn a Kubernetes job and monitor them without writing extra business logic. Let's look at one configuration parameter for job management. And that parameter is maximum job running time. It tells the framework the time within which a job is supposed to be completed. In this case, it is 300 seconds. If the job does not complete within 300 seconds, the framework will log an error and generate an error metric, which in turn will trigger an alert. And this does not require any extra coding on the part of the developer. On receiving the alert in a Slack channel, support engineer on duty will start investigation. The interesting thing to note here is how job management is integrated with Opentelemetry to provide a rich error handling capability and ease of support without requiring any extra effort on the part of the developer. And this integration exists for all components. The Create Job API allows the developer to create a Kubernetes job, passing it the appropriate payload and labeling it. In the last 3 slides, we presented only a few samples. The functionality of each component in the framework is exposed via a set of configurations along with the necessary APIs to serve all the use cases. So, how do we measure the effect of the framework on the developer-ready platform? We see that it has increased velocity, has cut down on bugs, made support easier. Last but not the least, the developers like it, and that is one great data point about the success of the framework. Thank you all for participating. We hope you enjoyed the presentation. Please contact me or Bob in the PlatformCon Slack for further discussions or if you have questions. Thanks once again.